So good morning, everyone, and welcome to this lecture. This is lecture number 9, and we are dealing with series parallel combination of registers. In the previous class, we had seen the series and parallel thing. We had seen parallel combination. What happens in parallel combination? Yes or no? The voltage is same, but the current flowing through different branches may be different. We also saw how current divides in two parallel branches. We had seen this formula. This is the question that is more likely to come. We also saw how charge divides. Charge divides in direct ratio of capacitances. Do we remember this? We also saw one question which was current dividing in three parallel branches. Do you remember that formula? Okay, what we'll do in today's class is we will write all these things together, series and parallel combination together in one table so that you are able to understand it if it comes in the examination hall. And these are the things that are going to come. So please be very careful in noting them down. If you have any problem, let me ask me. I will first just tell you what to write, and then you can go on and writing this. So on the left hand side, you see the series combination, and on the right hand side you see the parallel combination. Yes or no? Series parallel. And in series combination current is same. You can see current is same, I current is same, and the voltages are different. This voltage is directly proportional to R, so you can write V1 is to V2 is to V3. The ratio of voltage will be equal to R1 is to R2 is to R3. Do we understand this? Voltages will be in the ratio of R1 is to R2 is to R3. Power is also directly proportional to R, and therefore the ratio of power in the three registers will be in the same ratio. Do we understand this, everyone?
Yes, sir.
This series combination. On the left hand side, on the right hand side, we have the parallel combination. In parallel combination, as you can see, voltage is same, but currents are different. Current, how does it divide? So you must remember that current is inversely proportional to R. I have already told you. You can also add here that I1, they can ask you, is to I2 is to I3 will be equal to 1 by R1 is to 1 by R2 is to 1 by R3. Similarly, the power in this case is also inversely proportional to R. So P1 is to P2 is to P3 will also be equal to 1 by R1 is to 1 by R2 is to 1 by R3. Do we understand this?
Yes, sir.
I'll give you 2 minutes so that you can note it down. Note it down, please. Well, then we move on to the next point. We already know how to find out the equivalent resistance in case of series. It's R1 plus R2 plus R3 and so on. And remember, this equivalent resistance is greater than the maximum value of resistance. So it is always higher than the highest value. But on the left hand side, on the right hand side, 1 by R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3. And you can write this formula for three resistance in parallel. This will be the formula for three resistance in parallel. If we have two resistance in series, R1 plus R2. If you have two resistance in parallel, it's R1 R2 upon R1 plus R2. We remember this, everyone?
Yes, sir.
If we have n resistance, equal resistance in series, it is nr. The voltage across each of them will be V by n. If we have n resistance in parallel, the voltage across them will be R, the equivalent resistance will be R by n. and the current across each of them will be total current divided by N. We understand this?
Yes, sir.
Note it down in your notebooks. Then we move on to the next point, and if we have two resistance in series, and the voltage across them is V1, V2, and the total voltage is V. We can write V1 as R1, same ratio, direct ratio, R1 upon R2 into V, and you can write V2 as R2 upon R1 plus R2 into V. Do we remember this? Yes or no?
Yes, sir.
Similarly, if there is a parallel combination, how does current divide in parallel branch? I told you it divides in inverse ratio. So again, that is the inverse ratio. I1 will be equal to I into R2, and I2 will be equal to I into R1. Just note it down once more so that you don't forget it. I'll give you 2 minutes. Once you are done, please let me know. Everyone understands this? What is there on the board?
Yes, sir.
Please note it down. So we are done with this. Now let me go ahead. We had done a series parallel combination of resistance and capacitance. Do we remember it?
Yes, sir.
Do we remember how to find out the series parallel combination? Yes or no?
Yes, sir.
Okay, let me check whether you know it or not. So I'll give you one or two problems, and you have to tell me what is the what is the resistance, equivalent resistance in different cases. So let me see if you remember anything. And this is the first question. You have to find out the equivalent resistance between point A and B. This is the point A and this is the point B. You have to find out the equivalent resistance between the point A and B. Do you remember how to do this?
Yes, sir.
Good. Then I'll give you 2 minutes to give me the answer for this one. If you remember it, then we'll move ahead. So, how are you supposed to do this? Let's see. This R and this R, they are in what type of combination? This R and R. I start from one end. R and R. This R and R are in what type of combination? Series or parallel?
Series, sir.
So R and R in series will become how much?
2R.
2R. Now look at this 2R and look at this 2R. How are they connected? This 2R and 2R.
Parallel.
2R and 2R in parallel will become how much? 2R and 2R in parallel will become how much?
1 by R, sir.
Take a deep breath. 2R and 2R in parallel will become how much? 1R, sir. Yes, R, sir. R, not 1 by R, sir. R, sir.
Ah, okay, okay, okay.
Now this R and R are in which type of combination?
Series.
So R and R will become how much, sir?
2R.
2R, sir. Now this 2R, sir, and this 2R, sir, are in which type of combination?
Parallel.
How much will that become?
R.
See, it is so simple. Now this R and R are in which type of combination?
Series.
How much it becomes, sir?
2R.
2R, sir. Now this 2R, sir, and this 2R, sir, are in what type of combination?
Parallel.
How much it becomes, sir?
R.
R, sir. Now this R and R are in which type of combination?
Is combination.
So how much it becomes, sir?
2R.
2R, sir. Now this 2R, sir, and this R, sir. Oops, wrong color. Now this 2R and R are in which type of combination, sir? Parallel.
Parallel.
That is your answer, sir. What is the answer, sir?
Wait.
2R and R are in parallel, sir.
अरे what 2R is 2R. So 1 plus 2. 3 by. Sir, sir 2R by 3?
Yes, 2R by 3 is the final answer, my dear friends. 2R by 3. Do we understand how we got this, sir?
Yes, sir.
Pakka, sir?
Pakka, sir.
Okay. Let me give you this one, sir. Next question, sir. This one, sir. You have to find out the effective resistance between A and B points, sir. Yes, sir. And I'll give you 2 minutes, sir. Give me the answer, sir. I think that is the answer, sir. This 3 and this 7 are in what type of combination, sir?
Series.
So how much it becomes? 10.
10.
Then this 10 and this 10 are in what type of combination?
Parallel.
So it becomes how much?
5.
Then this 5 and this 5 are in what type of combination?
Series combination.
Correct. So it becomes how much?
10 ohms.
Then this 10 and 10 are in.
Parallel. Parallel combination.
So the answer becomes 10 and 10 in parallel. The answer becomes 5
5 ohms.
ohms, sir. Well done, sir. Good one, sir. Chalo, sir. Next one, sir. This one, sir. This has come in your exam, and this type of question is more likely to come, very likely to come. So tell me the answer for this one, sir. In the given figure, what is the equivalent resistance between point A and point B? I'll give you 2 minutes to give me the answer. So how are you supposed to do this? It's difficult to find which are in series and which are in parallel. But there is one thing that you can see. What you can see? 3 by 6 is half, 1 by 2. 4 by 8 is also 1 by 2. If I call this as R1, if I call this as R2, if I call this as R3, if I call this as R4, if I call this as R5, here R1 by R2 becomes same as R3 by R4. Do you remember what was this called known as? Balance Wheatstone Bridge, my dear friends. Do we remember Balance Wheatstone Bridge? If you remember Balance Wheatstone Bridge, this is a Balance Wheatstone Bridge. So you can cancel this one. This resistance does not come into the picture. Do we understand this? Then this 3 and this 4, they come in series. 3 and 4 in series becomes 7 ohms. We understand this. This 6 and this 8 will also come in series. That will become 14 ohms. This 14 ohms and this 7 ohms will come in parallel. So the equivalent resistance will become 7 into 14 divided by 7 plus 14. And the answer would be 14 by 3. That is option number A. Do we understand balance Wheatstone Bridge? Boys and girls, girls and boys. Do we understand this?
Yes, sir.
Everyone gets this? Yes or no? No, yes.
Yes, sir.
In the condition of balanced Wheatstone bridge, if I call this point as C and if I call this point as D, potential of C becomes equal to potential of D. Do you remember this? And no current flows in this branch. Do we remember this?
Yes, sir.
Pakka, sir?
Yes, sir.
Okay, sir. Then next question, sir. I hope that you can give me the answer to this question, sir. More likely to come. It has come many times in your exam, sir. So let's see, sir, what is the answer for this one, sir. In the combination of resistance shown in the figure, the potential difference between B and D. Where is B? B is here. Where is D? D is here. The potential difference between B and D is zero. B and D is zero. What is the value of the resistance X? Unknown is X. And you have 2 minutes to give me the answer. So how are we supposed to get this? It is given that the potential difference between points B and D is zero. B and D point the equivalent, the potential is zero. That means this has to become a balanced Wheatstone bridge. Yes or no? No, yes.
Sir.
Yes, sir. So this 12 and this 4 are in series, sir. So it becomes how much, sir? It becomes 16. Yes or no?
Yes, sir.
These two are also in series. 3 and 1 in series becomes 4. Yes or no? This 1 and 1 are in parallel. 1 and 1 in parallel becomes half. Yes or no?
Yes, sir.
The ratio has to be same. The ratio has to be same. That means 16 by 4, which is nothing but 4, will be equal to x divided by half. Divided by half means 2 comes in the numerator, 2x. So x becomes simply equal to 2 ohms. That is the answer that we are looking at. Do we understand this? Yes or no? No,
Yes.
yes.
Yes, sir.
Pakka, sir?
Pakka, sir.
Okay, sir. Then this next question, sir. Remember, one of these questions is going to come in your exam, sir. This is the next question, sir. A wire has a resistance of 12 ohm. It is bent in the form of a circle. The effective resistance between 2 points on any diameter is how much? Oops. I'll give you 2 minutes to think about this question. Yes. How are we supposed to do this? Well, if I just show you this diagram, this is any diameter of the circle. I can draw any diameter like this. I have to find out the resistance between these 2 points A and B. Yes or no?
Yes,
The
sir.
resistance of the total wire is 12 ohms. So the resistance of the upper half will become 6 ohm, and similarly the resistance of the lower half will become 6 ohm, and these two halves are in parallel. 6 and 6
Parallel
are in
series.
parallel. Eh?
Yes.
6 and 6 are in parallel. The answer is 6 and 6 are in parallel. The answer is
3 ohm.
3 ohm. Do we understand this? Yes or no? No, yes.
Yes, sir.
Okay. Now let me put this question in this form. Again, you have a wire whose resistance is, let us say, R. The resistance of the total wire is R. one circle, and this angle alpha is, let us say, 120 degrees. Do we understand 120 degrees? Then I have 2 points x and y. Can you find out the equivalent resistance between x and y? Now, the last question was across diameter. This is not a diameter. It is not equally divided. Do we understand this, everyone? I'll give you 2 minutes.
So can you explain it again?
There are 2 points x and y. The angle is 120 degrees. Previously, we had found out between these 2 points, the angle was 180 degrees. Now the angle is 120 degrees. Do we understand this?
Yes, sir.
Wire is bent in the form of a circle. The total radius, total resistance is R. This angle is 120 degrees, x and y. You have to find out the equivalent resistance between x and y. Everyone got this? Yes or no?
Yes, sir.
2 minutes you have. So, bacha, how are we going to do this? Any idea? Now see, any question that comes of this, you must know that resistance is rho L by A. You remember this formula of resistance? Yes or no?
Yes, sir.
Now, the wire is same, the area is same, the resistivity is same. So you can say resistance is directly proportional to the length of the wire. Yes or no?
Yes, sir.
The part which has more length will have more resistance. The part which has less length will have less resistance. Yes or no? Now,
Yes, sir.
this part is 120 degrees and the remaining is 240 degrees. Yes or no?
Yes, sir.
That means the length of the first half is half of the other part. Yes or no? The total resistance is R. If I call the resistance of this half, the green half, if I call the resistance of green half as R1, and if I call the resistance of the blue half as R2, do you understand what I mean to say? R1 plus R2 will be equal to total resistance R, yes or no?
Yes, sir.
And R1 by R2, it is in the proportion of length, so it will be equal to 1 by 2, yes or no? They are divided in the ratio 1 is to 2, so I can understand and I can find out that R1 will be equal to R by 3 and R2 will be equal to 2R by 3. Do we understand this? The entire circle is divided into two angles. One angle is 120 degrees. In the previous case, it was 180 degrees. So, upar wala half and niche wala half, they were of equal length. Therefore, 6 and 6, they become half each. Understand my point? Now, these two resistances, R1 and R2, are connected in parallel. So, the equivalent resistance becomes R by 3 multiplied by 2R by 3 divided by R by 3 plus R by 3, R by 3 plus R by 2R by 3 will be equal to R, and that will be the answer for this question. Do we understand this, what I have done here? Everyone understands? This total angle is 360 degrees. One angle is 120 degrees. The other angle is 240 degrees. Therefore, the length of the second part is 2 times the length of the first part. We understand this?
Yes, sir.
Okay, then this brings us to an end for today's class. This is the most tough question that can come for you. The question that I just did before that, That is the question that is more likely to come. Do we understand? Can you do a question of this type? Yes or no?
Yes, sir.
Okay, then on this note, we will end today's class. In the next class, we'll move on to Kirchhoff's law and see how we can use those Kirchhoff's law and solve questions according to that. Everyone has understood what we have done in today's class?
Yes, sir.
Well done, and I'll see you tomorrow. Take care, and may God bless all of you. Bye bye.